Section 7.3 is about using functions involving a number called e. Yes, e is a number, believe it or not. E is approximately 2.71828182845 and so on and so on and so on. E is called a transcendental number, just like pi. Pi is a transcendental number. It means that it goes on forever and ever and ever and never repeats. So that's why we have an approximation of e. There is a button on your calculator that gives you e, and we'll go through that more in class. The first thing I want to talk about is simplifying expressions with this natural base called e. If you had e to the fourth times e to the third, the same rules apply that you've been doing the entire last chapter. When you multiply something with the same base, you add exponents. So e to the fourth times e to the third would be e to the seventh. Pretty simple. If you have 10 e to the third divided by 5e squared, same rules apply. When you divide, you subtract exponents. So you divide 10 over 5, which would be 2. And when you divide e to the third divided by e squared, subtract exponents. 3 minus 1 is just e to the first, and I don't have to write that little 1 there. I could just write 2e. Here, you have a power to a power, so you need to multiply exponents, but this whole thing is squared. So you also need to do 3 squared, because you have to square each term, and then your e, you're going to multiply your exponents, so 4x times 2, because when you have a power to a power, you multiply. So this would be 9e to the negative 8x, and that would be your answer. Alright, let's move on to graphing. You're actually going to graph these the same way you graph the other exponential functions, so there's really not that much difference. I still want you to plug in 0 and 1 into x, and you're going to graph the same way. These functions involving e are still exponential growth and exponential decay functions. So that's what you're going to see here is another exponential function. It just changes at the rate of e, because e is your b now. Instead of b, you have a times e to the rx. So instead of looking at y equals a times b to the x, which you've been doing, now e is there instead of b, so that's your growth rate, and you're going to have r times x. In other words, some number times x. Like here in this example, we have 0.25 times x, so 0.25 is your r. And just a little side note over here, if a is greater than 0 and r is greater than 0, then this is an exponential growth function. And if a is greater than 0 but r is less than 0, this is an exponential decay function. So just by looking at this, 3 times e to the 0.25x, our a is greater than 0 because it's 3. And our r is also greater than 0 because it's 0.25. So this should be a growth function when you graph it. So if you plug in 0, we have 3 times e to the 0.25 times 0. Well, that's just 0. E to the 0 is 1, so that's 3. So our first point is 0, 3. Let me use a different color so you can see my dot. 0, 3. Alright, if we plug in 1, we have 3 e to the 0.25 times 1, and when you multiply that all out, you get about 3.85. Now you're going to have to round these because I said e is a transcendental number, so it goes on forever and ever and ever, so your answers will do the same, so you just round. To 2 decimal places should be plenty. So you got the second point, 1 and 3.85, so somewhere around here. Okay, when you graph these, same thing applies. The x-axis is your asymptote, and it's going to increase like that. There you go. Alright, let's do one more with some shifting. Now this is a little bit different because this is also a decay function. So there's one additional rule when you're dealing with decay functions. I still want you to plug in 0, but since this is a negative exponent, that means it's going to be decaying. That means that it's going to start over here on the left side and go down. Now with these functions that involve this e, if you have a decaying function, there's not going to be any value on this side of the x-axis because it's going to be approaching 0. So nothing's happening. So what you need to do is plug in negative numbers. So if this is a decay function, you need to plug in 0 and a negative number. You can plug in -1. I'm going to plug in -2 just for the heck of it. Doesn't matter. So if I plug in 0 into x, and if you remember when you have shifting and translating going on, just look at this part with the x first, and then you'll shift it, moving across and up or down afterwards. So we're just looking at y equals e to the -0.75 x first, and then we'll shift it. So if we plug in 0 in for x, we're gonna get 1, and if you plug in -2, you should get 4.48. So if we graph those points, 0, 1, and -2, 4.48, somewhere around here, and we graph this. Now your next step is to now shift it. So your h, since this is x minus 2, your h is 2 and your k is 1. So you're going to move it to the right 2 and up 1. So I move each point to the right 2 and up 1. So right 2, up 1. And draw my new curve. With my new asymptote of 1, because I moved everything up 1, so the asymptote moves as well. Alright. The last thing I'm going to give you is about this compound interest formula. I gave this to you last time in class, and you used it whenever you were talking about compound interest. Well, now we have a formula that uses e. So this is whenever you would have interest that compounded continuously, all the time. We would use the formula a equals p e to the rt. A equals pert. If you can't remember that, a equals pert. P is the principal amount, that didn't change, your starting value. R is the rate as a decimal, and T is time. So everything means the same, it's just that you have an E instead of your 1 plus R over N. So let's use this in a formula. Or I'm sorry, in a problem, not a formula. You deposit $100 at 7% compounded continuously. So continuously means we're going to use that formula. What is the balance after 1 year? So we have A equals pert. P is our initial amount. Our initial amount we deposited was $100. Then we have E raised to the power of RT. R is our rate. Well, we're compounding at 7%, and as a decimal that's 0.07. And then times T. It wants to know the balance after 1 year, so our T is 1. So if we go ahead and do that math, you get 107.25. So you earned $7.25. Woohoo!